Last week we were talking about transformations of graphs and what it does. And it doesn't really matter what the graph is, what the parent function is. The function is always going to do the same thing. For example, f of x plus 3 is going to move this graph up 3 places. So if I was going to graph it out, let me change my color here, it's just going to move every point up 3 places. And then I would just draw that in, and that would be f of x plus 3. If I had f of x minus 2 minus 1, well, this is going to shift it down 1 place, and this is going to shift it to the right 2 places. So it's going to shift over 2 places, down 1. 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 And then I would just draw my graph in, and that's what that function would look like. So when you're shifting a graph around, the numbers inside the parentheses on the outside, they all do something. They're going to either, if you have a negative in front, it's going to flip it upside down. So that's what we talked about last week, is talking about the transformations of graphs. Now this week, I want to talk about that this is what is considered a long week. And what that means is that week number 12, we don't have school next week on Wednesday, Thursday, and Friday. So this week will be Monday, week number 12 will be Monday, Tuesday, Wednesday, Thursday, Friday, and then the following Monday and Tuesday. Since there won't be any new material next week, there aren't any live sessions or help sessions. So next week would be a great time if you're behind to use that time to get caught back up. This week we have something that's fairly easy to do. We're dealing with arithmetic combinations of functions. We're going to add them, we're going to multiply them, we're going to divide and subtract, and then we're going to do composition of functions also. So really not a very difficult week this week. So for example, what I'm talking about is if you had a function f of x equals 2x minus 3 and g of x equals x squared minus 1, and I asked you to do f of x plus g of x, that is called a combination of functions. All we're going to do is we're going to take the f of x function, so 2x minus 3, and we're going to add the g of f function, so g x squared minus 1, and then we try to write it in terms where the highest power to the front. So I would rewrite this as x squared plus 2x, and then the minus 3 minus 1 would be a negative 4 there. So that's basically what we're going to be doing this week, is we're going to be combining functions. Now, you can add them, subtract them, multiply them, and then we're going to do compositions also. Now, if you have subtraction of functions, it's a little bit more difficult because we have to make sure that that subtraction goes to both terms. Okay? So that's the one thing that you have to worry about when you're subtracting. Multiplying, you just multiply, you would do FOIL. Dividing is a little bit tougher. You try to factor out the greatest common factor and simplify it. The domain of an arithmetic combination of functions, f and g, consists of all real numbers that are common to the domains of f and g. When you're doing f divided by g, there's a further restriction that g of x does not equal 0. Okay, so you have to be very careful that the denominator can't equal 0 in those types of functions. Arithmetic combinations. F plus g of x is the same thing as f of x plus g of x. F minus g of x is the same thing as saying f of x minus g of x. F times g of x is the same thing as f of x times g of x. And f divided by g of x is the same thing as f of x divided by g of x. So if they give us a function like this, if they say given f of x equals 2x plus 1 and g of x is x squared plus 2x minus 1, find f plus g of x, basically what they're saying is find and then evaluate when x equals 3. What they're really saying is we're going to take f of x, we're going to add g of x together, and then we're going to plug in 3 at the end. Okay, so if I did that, f of x is 2x plus 1, g of x is x squared plus 2x minus 1. So if I add this together, f plus g of x is going to equal x squared plus 4x, because the plus 1 and minus 1 are going to cross off. And then I'm going to, but the final thing is they wanted us to find, f plus g of 3. So that means I'm going to plug 3 in here. So 3 squared is 9, plus 4 times 3 is 12. So my answer would be 21. Now here's the type of problem that you'll get on the assessment. Anytime they put an x here, that means you're looking for the function when it's added or subtracted or multiplied. Now if there's a number here, then they want a value. And all three of these problems, they just want me to do the function trying to multiply, like this one is just g times k. So I just take the g function, that's x squared, times the k function, well, that's square root of x. All right, well, if I multiply these together, usually when I do a multiplying, I'm just going to change the square root of x to x to the 1/2. Bases are the same, so I can add the exponents. So this is going to be x to the, we have 4 halves here, so 5 halves. That would be my new function. This one, it says g plus h of x, so I find the g of x, or the g of x function, which is x squared, plus the h function, which is x minus 8. That looks like I don't have to do much. It's already done. Here I have g minus h, so the g function is x squared, minus, now this one's a little bit trickier, because this minus sign goes to each term. So this is going to end up being x squared minus x plus 8 as my function. Now, when they have a number here, that means we have to plug the number in. These look like, right? So the first thing I would do in a problem like this is it's asking me to plug 9 into the k function. Okay, so I'm going to plug 9 into the k function. K function's way over here, so I put 9 in here. Square root of 9 is 3. So then I'm going to rewrite this as g of 3. So now this is telling me, hey, plug 3 into the g function. Okay, well, the g function's here, so if I plug 3 in here, 3 squared is 9. Huh. This problem here, now these are called composite functions because it's a function inside a function. So here it's asking me to put negative 3 into the g function. So negative 3 squared is 9. And then now it's telling me to put 9 into the h function. Well, the h function is here, so 9 minus 8 is 1. This problem is telling me to put negative 3 into the h function. So negative 3 minus 8, that's negative 11. Now that I have to plug into the g function. Well, negative 11 squared is 121. Practice problem. If I was going to do this practice problem, it says f of g of x. So it says that we want, we're going to add these together. Since this is x, it just means that we want a function when we're done. We're not going to plug a number in there. So I'm just going to add these two functions together, x plus 3 plus x minus 3. So that gives me 2x would be my function. F minus g of x, okay, again, it's just an x value here, so I'm going to end up with a function when I'm done. So that's just going to be x plus 6 minus x minus 6. Well, that minus sign goes to both of these terms. That gives me minus here, plus here. So negative x and x is 0. 6 plus 6 is 12. Composition of functions. Composition of function, we did a couple of them before. A composition of functions is when you have a function inside of a function. Okay, so if it asked me to find f of g of x in this problem, well, what I always do in these types of problems is like, I know what g of x is. G of x is x plus 1. So in place of g of x, I'll put x plus 1. Now this is telling me to plug x plus 1 into the f function. Well, the f function is right here, so I plug that in, so this would be x plus 1 quantity squared. Just plugging it into my f function. So if I'm given a problem like this, that little 0 in there really means composition of functions. So if I'm given a function that looks like this, f of g of x, I usually write it this way. F of g of x means exactly the same thing. Here, g of f of x, that would be g of f of x. And here, this would be, now this is a number here, so this is going to be g of f of -2. All right, so if I'm going to do this problem, first thing I'm going to do is I'm going to put g of x right where I see it. So I'm going to rewrite this as f of 4 minus x squared. And then I have to put 4 minus x squared into the f function. Well, here's the f function. So that's going to be 4 minus x squared plus 2. So my answer is going to be -x squared plus 6. If I have g f of x, okay, well, I know what f of x is. It's x plus 2. So I'm going to rewrite this as g of x plus 2. And then this is telling me to plug that into the g function. Well, the g function is right here. So that's going to be 4 minus x plus 2 quantity squared. Now, usually, you have to multiply this out. So this is going to be 4 minus, and then x plus 2 squared. Well, isn't that x squared plus 4x plus 4? It's all inside parentheses, so that minus sign goes to everything. So that's 4 minus x squared minus 4x minus 4. So those are going to cross off. So I'm left with -x squared minus 4x. Now, if there's numbers instead of a variable like an x, now they're looking for a value. And I think these are a little bit easier. So this is saying, hey, put -1 into the g function. So the g function's right here. If I put -1 here, -1 squared is 1, minus a -36. So that's going to be 37. So this is going to be f of 37 now. Well, this is saying, hey, put 37 into the f function. Well, that's -1 over 37 then. That is it. So when you have a number instead of a variable, all you're doing is just plug that number in. For example, this one, I put 0 into the g function. Well, g function's here, 0, 0, that's 0. So now it's telling me to put 0 into the h function. Well, the h function is right here, so 6 minus 0 is just 6. And these are all different types of problems. You know, see x here, and then you would just you're gonna end up with a formula when you're done, or an equation. Practice problem, g of f. Okay, so I would rewrite this as g of f of x. Well, I know what f of x is. That's x to the third. And I have to plug x to the third into the g function, so that's going to be x to the third minus 1. Letter A. Here I have f of g. Okay, so this time I would rewrite it this way, f of g of x. Well, I know what g of x is, so I'm going to plug it in there. So that's x minus 5. And then that's telling me to put x minus 5 into the f function. Well, the f function is x squared. So this is just going to be x minus 5 squared. And I don't have to multiply it out because my answer is right here.